So we're doing more factoring. We're doing factoring until the end of the year, okay? That's basically what we're doing. Well, the end of the week. I don't think I'm going to, well, I might teach one new thing maybe on Monday and Tuesday. I don't know. We'll see how it goes. All right, but it's still factoring. Everything we're doing in here is factoring, which is a very, very, very important part of doing math, okay? In and of itself, it's not that important, but you got to be able to factor stuff to be able to do other things, all right? That's what math is. A lot of people get, oops, I don't have my mic on. A lot of people get all hung up on, well, I'll never use that the rest of my life. I've started, by the way. I don't know if you noticed or not. So a lot of people think, well, just doing this factoring, what am I going to do in life where I got to factor this thing, okay? But if you went on to be an engineer, if you went on to be an architect, if you went on to do something, if you did something in the math world, okay, there's going to be times where you're going to have to factor some stuff, right? Is that the only thing you have to do? No, it's just part of the process, okay? It's like crawling before you walk kind of thing, all right? That's what this is about. So that's why we're learning this, okay? We're not learning this just for itself. It's not like you're going to go out and get a job and say, hey, I can factor by grouping, you know? They don't care. This is in order to be able to do other things, higher math. That's what this is all geared towards. It's geared towards higher math. And I know some of you are thinking, I know exactly what you're thinking. You're thinking, well, I'm not going to be doing any higher math, so why do I got to do this stuff? Well, best case scenario, this helps you think and it helps you process things. In any job in your life, no matter what you do, you're going to have to think, you're going to have to process information that's coming in, you're going to have to do stuff with that information. Is it always going to be math? Of course not. But this helps your brain think in a certain way, all right? So that's why I think it's important to do math. I saw a meme the other day, and I've seen it for years and years, but somebody tagged me in it and said, hey, Mr. Hamrick, another day went by and I didn't do any algebra. I'm like, yeah, okay, I get it, all right? I understand. But has a day gone by where you haven't had to think about problems and try to solve a problem? Rarely, okay? Rarely a day goes by. Not talking math problems, okay? I'm just talking about life problems. That's what math does for you. It helps you think in a logical manner. And that's why it's important, okay? Not just like difference of two squares. That's not what's important. It's about looking at it and getting your brain to think a certain way. That's why I think math is important, okay? So all those memes, they think they're funny. And yeah, it's a little humorous. I get it, all right? But you got to think. Every day you got to think. And that's what I'm trying to get you to do. I'm trying anyway. All right, let's do this. Difference of two squares. Well, let's talk about what a square is. You know what a square is, like geometrically. But it has to do with that, but it's not exactly what we're talking about today. Let's talk about a thing. It's called a perfect square. I want us to understand what a perfect square is. So we're going to start with regular numbers first. And then we're going to do some other things, throw some letters in there, throw some variables. Well, letters are variables, but throw some exponents in there and all that kind of stuff. So let's list a whole bunch of perfect squares. In the book, they list 20 of them. I'm not going to list that many. I'm going to list, 12 of them, all right? So the first perfect square is 1 squared. So if I take a number and I square it, that's a perfect square. So what is 1 squared equal to? It's 1. What's the next number? 2. What if I square that? What do I get? I get a 4. What's the next number? 3. If I square that, I get a 9. All right? I'm not going to write the 1, 2, 3, 4. What's the next one? After 9, in your head, let's think about this. Let's think. That's what I'm trying to get you to do, is think. What's the next one? It's 10. Look, it's 1 squared, 2 squared, 3 squared, so it's going to be what? 4 squared, which is 16. Then, which is 25. Then, just give me the number. Just think in your head and give me the number. 36. 49. 64. Why 64? Because this is what? 7 squared. This was 6 squared. This was 5 squared. This was 4 squared. I guess I am writing these down. What is this one? This is 8 squared. What's the next one? 81, because 9 squared is 81. What's the next one? It's 100, because 10 squared. What's the next one? Yep, 121 is 11 squared, and we'll stop at this next one, 144, okay? You could go on and on, couldn't you? You could go on forever if you wanted. These are what? Perfect squares, okay? They're considered perfect squares. You can also have perfect squares with letters and exponents, okay? For instance, if I just took an x And I did what to it? What did I do to every single one of these numbers here? I squared it. So what would be the perfect square for x? It'd be what? X squared. So that's a perfect square, okay? What about x cubed? Is that a perfect square? It's not, okay? Because if I take the square root of it, I got an extra x left over, don't I? All right, so it's not a perfect square. All right, so look at all these numbers. Not all of them. Because 49's not, 81's not, 121's not. What was I going to go with there with this? But every time you have, forget what I was going to say there. Went on the wrong track. What if I had something like this? What if I said x cubed? What's x cubed squared? What if I squared an x cubed? We did this not too long ago. Well, after squaring it, it's a perfect square. So what is x cubed squared? X to the what? X to the 6. We multiply. When I take an exponent to another power, I multiply the exponents together. Okay? So that's x to the 6. Now, here's the question. Is x to the 6th a perfect square? Yes, because I'm squaring something to get x to the 6th. Follow me? What am I squaring to get 49? A 7. What am I squaring to get 100? A 10. What am I squaring to get x squared? An x. What am I squaring to get x to the 6th? X to the 3rd. Everybody with me on that? All right. And we can have some more. Here's some more. And then we'll get into something that we really want to do. What about this? Is this a perfect square? Is that a perfect square? Are you squaring something to get each one of those?
No. You only square x. You only square x and y.
Really?
Aren't you times x? Right?
What's that?
The z doesn't count.
Done?
Well, aren't they even?
We already did it. We did it right here. We did it right there.
X squared is x squared.
Yeah.
Y squared.
So look, what's being squared here? We went through this. What's being squared to give you x squared? X. What's being squared to give you y to the 4th? Y squared, right? Y squared, okay, is y to the 4th. Agreed? Now, what's the z? Z to the 3rd. All that is being what? Squared. So, is this a perfect square? Yes, that's a perfect square. So, what I'm doing with this stuff is just to get you to recognize what's a perfect square, because we're going to do things here in a second with perfect squares, okay? I just want you to be able to look at it and say, oh yeah, that's a perfect square. I'm squaring that number to get that number, right? I'm squaring this stuff to get this. Time.
So for that z
Yeah.
on the outside there, we're just dividing it by 2 to get it.
Basically, yeah. Yep. Yeah, if I had something like z to the, 24th, what am I squaring to get z to the 24th? Z to the 12th, that's right.
So if something
Okay.
doesn't divide equally, then it's not.
Exactly right, okay. Well, you can't really say that, though, because look at 81. All right, that's not an even number, but when we're talking exponents, you're right, okay? Okay, so when we talk about exponents, so every exponential equation or expression, okay, that has an even number exponent, that's a perfect square. Because you could always square it. You could always divide it by 2, right? Yeah. But if I had x to the 9th, is that a perfect square? No. All right? Everybody with me on that? Okay. So let's move on. Let's go back in time and let's take a look at this. Remember FOIL method? Wasn't that long ago. It seems like it's just the other day we talked about FOIL method. Just distributive property, okay? I'm doing this for a reason. We did this. We had problems like this, just not too long ago, a few weeks ago maybe. All right, so what is that? How do you do this? First, outside, inside, last, right? So what do we get? X squared. Then the outside is minus xy. Then the inside is plus xy, yes? And then the last is minus y squared. Okay, I'm not going to take a lot of time on that. We've done that before. There we go. What happens to the inside here, the outside and inside? Negative xy plus xy. What happens? Yeah, they do cancel, but let's say it better than that. They add up to what? Not to 1, to 0. They add up to 0. And yeah, we use cancel a lot for a lot of things. And it's okay to use it. I'm not saying you can't use it, but I want you to see what's actually happening here. They add up to 0. So what are we left with then? We're left with what? That's it. So what we're going to do now is we are going to take this. We're going to recognize that it's a special. They call these special, I didn't write it down, special products, I think, is what they call this. Okay, we had a little title to the lesson, and I think they called it special products, all right? The reason why it was special is this, because the outside and the inside will always add up to 0. So what we're going to do now, since we know a little bit about factoring, we're going to take this, and we are going to factor it and make it look like that, all right? So our problem now is going to be something like this. It's going to say factor x squared minus y squared. Now, up to today, what was the only way we could factor? If we found a what? A greatest common factor. Do I have a greatest common factor here? I don't, all right? So, but that's the first thing I always look for. I always look to see if there's a greatest common factor. There is none. So you think about it and you're like, well, I can't factor it then. No, that's not right. All right. Here we go. So we need a way to do this. Let's look at how we got from here to here, okay? Look at what we started with. We started with the x and the y were in both parentheses, agreed? What was the only thing different about both these parentheses? One was what? Positive, and one was negative. That's right. One had a plus, one had a minus. So in order to factor this, you need to recognize that this is a difference of 2 squares. All right, let's go back to this word. What does the word difference mean in math? Minus. You subtract. That's right. It's subtraction, okay? Of what? Of 2 squares, or 2 perfect squares. They just don't call it of 2 perfect squares. They just say of 2 squares. Everybody see that? So the title of this lesson and then the title of what this is about is super important, because you could recognize that it's one of those. So looking at this thing right here, you should be able to look at this and say, hey, wait a minute, I've seen that before. It's a what? It's a difference of 2 squares. So how do I factor a difference of 2 squares? That's right. Watch. Everybody watch. You watching? This is the first time we do one of these, so you got to watch. So what we do is we put 2 sets of parentheses next to each other. That's my factoring. Then what did I say we're going to do? Put a what? Put a plus and a minus in there. Okay? And now what we want to do is find what is being squared to give you x squared. What am I squaring to get x squared? An x. So I put an x here and I put an x here. What am I squaring to get y squared? A y. So I put a y here and a y there, and you're done. That is your first difference of 2 square factoring problem. These are actually some of the easiest factorings that you're going to do, all right? Because you look at it, you recognize it, and you're like, okay, it fits that pattern, all right? Difference of 2 squares are really nice, okay? They're one of the most gentle, I guess you could call it, easy. We use easy all the time, but it's one of the simpler factoring problems. It can get more complicated, and you're going to see in a few minutes. It does get a little bit more complicated, all right? But the basic difference of 2 square factoring is pretty simple. That wasn't even an official example. I'm going to give you an official example right here, all right? So here it is. It's example 1, and it says to factor. They don't give you any hints. They don't say factor it by using difference of 2 squares. It'd be nice if they did, but they don't. They just say to factor it. You have to recognize what it is. You know what? Before I do example 1, I wrote something else in my notes. Let's just push that down just a little bit. Let's do one more before we get to the example. You know how I started this thing out and I went x plus y times x plus y and we multiplied it out? Let's do the same thing. I just want to do it one more time just to show you. What if I had something like this? What if I had 3x plus 2y times, what do you think I'm going to write now? 3x what? Minus 2y. Good. All right. So you should be able to do this. It's distributive property, FOIL method, whatever you want to call it. You should be able to do this. So let's do it. First outside, inside, last. So what am I going to get? 3x times 3x? 9 what? X squared, not 2. X squared. Let's do the outside. So it's 3x times negative 2y, which is minus what? 6xy. Let's do the inside. Plus 3 times 2, that's a 6, and then an x and a y. And then the last, negative 2, or positive 2y minus 2y is negative what? 4y squared. It's not 4 squared, it's just 4y squared. What happens to the middle terms? They add up to 0, okay? They cancel out. You could say that, I guess, but I like to say they add up to 0. What are you left with then? 9x squared minus 4y squared, okay? Now, if you look at this, what is this? This is a what? A difference of 2 squares, isn't it? So pretend right here, pretend you didn't see that part, okay? Mentally cover it up with your hand, okay? What if you started with this? How would I factor this? Well, first of all, you look at it and you recognize, you see, is it a difference of 2 squares? Well, you got the difference, right? You got the minus. By the way, while I'm thinking about it, there is no sum of 2 squares. Everybody hear me? So if this was a plus, you couldn't factor it. You can factor it if it's a minus, though. All right? So if it's a minus, you could factor this. So what do? You say, well, I got the difference. I got 2 things. Are both of these things perfect squares? Is 9 a perfect square? Yeah, because I can square something to get 9. 3, right? Is x squared a perfect square? Sure. What about 4? What about y squared? Yes. So is this a difference of 2 squares? Absolutely. So how do I set it up? 2 parentheses. I always do this. I always put plus minus. Yeah. Some people don't. They just go right to the first thing. I always like to put plus minus right there. Now, what is being squared to give you 9x squared? A 3 and a what? And an x. So I put it here and I put it where? Right there. What's being squared to give you 4y squared? A 2y and a what? 2y. Now, we can uncover our eyes with that problem. Is that the same as that? Absolutely. Okay. Now you can shut the door for me. All right. It's not that hard. It really isn't. You just got to get the swing of things. So here's the first official example. And I'll let you try this on your own. It's very similar to what we just did. Very similar. So there it is. First of all, we look at it. Is it a difference of 2 squares?
No.
Well, there's a difference, right? Is something being squared to give you 49? Yeah. What is it? 7. What's being squared to give you x squared? X. What's being squared to give you 16? No, it's 4. It's 4. So is this a difference of 2 squares? It is. So now, once you recognize that it's a difference of 2 squares, it's super easy to do. So do it. Take 10 seconds. Go. Parentheses, parentheses, plus, minus. What is this? 7x. 7x. What's this one? 4, 4. I'm done. That's it. It's that easy. Do you agree? Yeah. Well, you know it's not always going to be that easy, right? Yeah, it never is. But this next one's not much different. It's not much different at all. Okay, then it starts getting a little bit. They ramp it up just a little bit. Again, they say factor. I'll write it down every time. I'll let you do this completely on your own. I'll give you like a minute. There you go. 1 minute. Go. Everybody should be trying this. Heads are down. People are sleeping. I know it's a little warm in here and it's dark. I get it. But come on. Have a little discipline. Sit up. Get a piece of paper. Write it down. It's what you're supposed to be doing. Once you get used to these, you'll get to the point where you just look at it and be able to just write down the answer. You hardly have to think about it. Megan, let's turn around. Let's keep your hands to yourself, please. Thank you. Let's face the front. I don't know. Ask this class before me. I'm sure that's where it came from. All right, so here we go. Look up here. Minutes over. Yep, it's minutes over. So first thing I do, well, first of all, I got to realize, is it a difference of two squares, first of all? Because sometimes they may throw one in there that's not a difference of two squares, and you can't do anything with it, okay? But look at this right here. You got the difference. Is something being squared to give you 64? Yeah, 8. Is something being squared to give you 25? Yes. Is something being squared to give you a to the 4th? What? A squared squared, right? And what's being squared to give you b squared? A b. So if you can answer all those questions, you can factor this with no problem. Put a plus and a minus, and then you've got 8, then what? 8 what? A squared. And then what's here? 5b. And this one's going to be exactly the same thing. So once you get one of them, you just write the same exact thing except for the minus. That's the only thing different. And then there you go. It's completely factored. There's nothing else you could do with that. Okay? It's not hard, is it? All right, this one's not much harder. I think, all right, I'm not going to write factor. I said I was going to write it every time. I'm not going to this time. X to the 4th minus 1. I'll just talk about it. I'm not going to let you do it because I got a few more I got to get through. So it is a difference of two squares. There's the difference. Is something being squared to give you x to the 4th? Yes. What about 1? Is something being squared to give you 1? Yeah. What? 1. 1 squared. 1 squared is 1, right? So yeah, is this a difference of two squares? Absolutely. First thing I do is put a plus and a minus. What's being squared to give you x to the 4th? X squared. It's not x to the squared. It's just x squared. And then 1 and 1. Now, got to be careful though. Now watch. Everybody watch. This is where we hit a little road bump. So far, we've circled our answers and we said that was it. We can't go any further. But we can actually factor this a little bit further. Where? Just the x squared? What else can we factor? Look at it. Come on. Put some thought into it. Come on. Come on. Everybody look up here.
The 1's going to be
The 1 will still be 1.
it's going to be a negative.
Oh, don't you combine the two?
No. If I multiply it, I might get back to where I started. I don't want to do that. I want to find out what times what is equal to this, but there's a little more factoring we can do. Where do you see it?
You can make it 4.
You could change that x squared to just x.
No.
Oh, wait, just make it x squared plus 1.
There's another difference of two squares in here. In the answer. In this answer.
Oh, the other one is a difference of 2 squares.
That's it. You see it now. Very good.
X squared.
Look at this.
Oh, because the negative.
Do you see that? That's also a difference of two squares, isn't it? All right. So we have to factor that as well. It won't be completely factored. Now, is it factored? Do I have something times something else that equals what I started with? I absolutely do. But it's not completely factored. And they always want it completely factored. Okay? So I'm going to take this and I'm going to factor that. It's still being multiplied by this right here. Shane, put your phone up here on my desk, please. You can get it at the end of class, as long as you don't give me any trouble. So now let's do this. Let's factor this. So what am I going to do? I'm going to put my 2 parentheses. I'm going to put a plus and a minus. And what am I going to put? What's being squared? X here, X here. What's being squared to give you 1? 1 here, 1 here. Now is everything factored? Yeah, I can't do anything with that. That's a sum of two squares. We don't have anything to do with sum of two squares. All right? So that's my answer right there. So you always have to look for that. Okay, like right up here. That potentially could be a difference of two squares, but is it? No, because 8's not a perfect square, 5's not a perfect square. So that's not. But always look for it. Since you saw it now you're probably going to see it every time. All right, that you might have to factor once, then you're going to have to do it again.
Is that only with the 1?
No, that has nothing to do with the 1. It just has to do with if one of these factors can factor again, you have to do it. Okay, let's do another one. Okay, I think we're learning something today. You guys never did this in Algebra 2? This is an absolute Algebra 2 topic. To tell you the truth, some courses in Algebra 1 would teach this. I think a lot of Algebra 1 classes would teach this. So you never did this? First time? That's all right. At least you're learning it now, so that's good. All right, this one's weird. They get a little bit weirder every one after this. Actually, I only got one more after this one. So this one and the last one's it. So let's take a look at it. It looks a little weird, but is it a difference of 2 squares? Do I have my difference?
Yes.
Yes, got my difference. So you need that. Okay, if that was a plus, you couldn't do it. End the story right there, okay? Look at this thing. Is this thing being squared? Yes, because if it has a even exponent, yeah, it's a perfect square, isn't it? What's being squared? X plus y squared is being squared. Let me write that down. X plus y squared, that thing is being what? Squared. What's being squared here? Z squared is being squared, isn't it? So is it a difference of 2 squares? Absolutely. So let's do this. Let's put 2 parentheses, put a plus and a minus. What's going to go where? What is being squared right there?
X plus y.
X plus y squared. That's right. I'm going to put that in parentheses. I'm going to square it. And then I put the other one here. What's being squared here? Z squared. And then I just fill the other one in exactly the same. So I just put it x plus y squared minus what? Z squared. It'd be nice if I could just circle it and I'm done. But you saw it. You got to do it again. Which one of these do you have to do it again? The right one. This one right here, okay? So I'm going to rewrite this, though. I'm going to write it down again because it's still being multiplied, right? So I'm still going to write this. So that plus this. All right, now look at this. Look at this one right here. That's also a difference of 2 squares. So we have to do that twice, right? We did it once to get to this. And then we're going to take this one. There's my difference. There's my squared. There's my squared. So now I want to factor that. So I put 2 parentheses, 1 plus, 1 minus. What's going to go here? What's being squared to give you this? X plus y. Not just x and y. X plus y. And then what's being squared here? Z. What do I put here? The same exact thing, right? X plus y. This time it's minus z. And there's nothing else I can do. Can I factor this thing here? Because it's a sum of 2 squares. I can't factor sums. So that is my answer right there.
Again, there will be a high school
Did you write it,
men's Bible study.
did you write it down?
12:15. Thank you.
Okay. We got one more. That'll be it. Got 5 minutes. Perfect timing. Last one, example 5. Again, it says to factor every one of these. This is a little shorter this time, so that's nice. Oops, it's not 24. It's 2x to the 4th y minus 32y. I said it really quick, really briefly, probably went right over your head, but when we do a factoring problem, the first thing you should always look for is to see if there is a what? A greatest common factor. Don't look right away for the difference of 2 squares. Look to see if there's a greatest common factor first, okay? Factor that thing out, and then you could look to see if there's a difference of 2 squares, all right? Let's look at this one. Is there a greatest common factor here? Is there something in common with both of these? The 2 and the 32? Yeah, 2 goes into both of them. Exactly right. What about the x's? No, because I don't have an x here. But there is one y here and one y here. So I can first of all factor out a greatest common factor, which is 2y. Okay? So that's the old stuff. The old stuff we did yesterday, that old. All right, so we factor out the 2y. What do I have left? If I factor out, if I take this and I divide that by a 2y, what am I left with? X what? To the fourth, good. Then put a minus. If I take a 2 out of this, I'm left with 16. No, remember, we're dividing. 32 divided by 2, 16. Then y divided by y is 1, so that's it. Am I done? Did I just have to factor out a greatest common factor? No, because now when you look at it, what do you see? You see another what? Difference of 2 squares. All right, so let's do that. Shouldn't be too hard. Put a plus and a minus. What do we got? What's being squared to give you that? X squared. So I put that here and here. What's being squared to give you 16? 4. Am I done now? I did it twice, right? I did 2 factorings. No, because you look at it again. Is there anything else that can be factored here? Absolutely. This thing right there is a difference of 2 squares. So I write all the other stuff down. Can I factor this? This looks like difference of 2 squares. Why isn't it? Because it's a sum, right? It's a plus. That's enough to make it not able to factor. Tomorrow, we're going to do a difference of 2 cubes, and we're also going to do a sum of 2 cubes. Now, with cubes, it does have a sum, all right? But not with squares, all right? Now I got you all excited, but you can't wait to come in tomorrow to do the sum of 2 squares. All right, so here we go. Let's factor this. This is easy now. This is super easy. Plus, minus, x plus what? 2, x minus 2. Is there anything else I can factor before I write? Nope, that's my answer right there. That's completely factored. All right, so what did I give you this time? Oh, you know what? Remember I said at the beginning of class 71 to 100? I actually assigned that for today, but we're going to skip that. We actually skipped ahead a day, so that's good. All right, I usually go back a day. So, no, we don't have homework. We're doing 15 to 43. So, we're a day ahead. All right, everybody hear that? We're a day ahead of the lesson plans, which I hardly ever say. We're not doing 71 to 99 odds. We are not doing that. Okay, we're doing 15 to 43, just the odds. It's not that many. And it's section 5.5.
What page is that?
And it's A. I don't know. Just look at the section 5.5. You'll find it. Okay? All right. Have a seat till the bell rings. You can talk, but just sit. Don't stand. Don't stand. Sit until the bell rings. Sit until the bell rings.